Hey everyone, and welcome back to Edritt. In this lecture, we are going to see the introduction to complements. We are going to see what are different complements available and see how we can calculate those complements. And then we're going to conclude the lecture. In the next lecture onwards, we'll see the details about the binary complements, which is ones and twos complement. So without wasting our time, let's start. So, so for a number system, for a number system which is which is radix R, we have two complements available. So that radix R, we have one is the R minus 1's complement available, and the second we have R's complement available. So let's say if you have R is equal to 10, which is decimal number system, so you have one 9's complement available, two 10's complement available. Similarly, if you have a radix 2 number system, which is a binary number system, you have 2 minus 1, which is 1's complement available, and 2's complement available. Similarly, if it is octal number system, you have 7's complement as well as 8's complement available. If it is hexadecimal number system, we have 15's complement as well as 16's complement available, but our focus will be more over these decimal and binary because they are only important. And the similar concept you can apply and also go for decimal and hexadecimal and octal if you want. So before wasting our time, let's try to understand this R's complement. Okay, so the R's complement of any number. Okay, so let's say if you are given a number, if you are given with a number with a number, okay, let's say n, let's say n, let's say n, then R's complement of that number would be equal to r raised to power n minus capital N. Now here this r represents the radix of the number system, radix of the number system. Okay, this n represents the number of integer digits, integer digits in the given number, and this r raised to power n in total is in decimal form. Okay, so this is decimal equivalent basically. This is a decimal equivalent operation, and this capital N represents the number itself. So number which would we would like to complement. Okay, now probably this formula will be looking pretty much complex and weird, but we'll try to solve this through an example and the things would be pretty much clear. Okay, you need to also recall this formula for certain cases, but the solvation of this complement is pretty easy. So let's try to understand this through an example. We'll take us directly a complicated example, which the complement is going to be though very easy. Let's take a random number which is 765.432.432 base 10, and you have been asked to calculate R's complement. Okay, you have been asked to calculate r's complement. In this case, that will be 10's complement. Why? Because the radix is why? Because the radix is 10. Okay. So when you are supposed to calculate 10's complement, what you have to do? You have to look at this formula. So r's complement is equal to r's to power n minus capital N. So the r's complement, which is here, yeah, I'll first write down the formula. R's complement is equal to capital small r raised to power n minus capital N. Now here the r is equal to radix. What is the radix? Radix is 10. This n is equal to number of integer digits. How many number of integer digits are there? 1, 2, 3. So this n would be 3. This capital N is the number itself. What is the number? Number is 765. Number is 765 765.432. This is my number, right? Now I have everything to calculate this r's complement, which is the tens complement of this number. I just have to put them in the formula and I get the value. So my tens complement will be equal to what? That will be equal to r raised to power n, which is 10 to the power 3 minus 765.432. Now when you extend this, which is in decimal form, and this is also in decimal form, so this will be 1000 minus 765.432. Okay. Now go to your kindergarten and see how we used to solve these problems. You have to write down this 1000.000, and then I have to write down 765.432. Okay, I have to put the borrow to each one of them. That will be something like, so here it will be 10 minus 2 8, here it will be 9 minus 3 6, here it will be 9 minus 4 is 5. Okay, 9 minus 4 is 5. Point. This also will be 9 minus 5 4, 9 minus 6 3, 9 minus, and this would be 9 minus 7 2. So your answer would be 234.568. So this is the tens complement form of this number. Now let's try to understand what is r minus 1's complement, which is also pretty easy. Okay, so let's directly jump in. So we will see r minus 1's complement of a number. So again, let's say you are given, similar to this case, you are given with a number system, let's say n. You are given with a number which is, let's say, n. Okay, again given with a number, let's say n, sorry, capital N. Okay, then your r minus 1's complement would be equal to what? That would be equal to r raised to power n minus r raised to power minus m minus capital N. Okay. Now, what does this n, m, and capital N represents? So this r firstly represents the radix of the number system. What does this n represents? It represents number of integer digits. This m over here represents number of decimal digits. Okay, number of decimal digits. This m over here represents number of decimal digit, and this capital represents the number itself. Okay. So this formula may be looking pretty much complex, but we'll try to understand that through a simple example. We'll take the same example and we'll try to do the 9's complement of that, which is equivalent to 9 minus r minus 1's complement of a decimal number. So I'm taking the same example, which is 765.432, which is a base 10 number system, and they're asking to calculate the 9's complement. Okay. Now, how can we calculate this 9's complement? Simply go to this formula, just map this formula, map the specific terms, which is the r minus 1's complement. R minus 1's complement is equal to r raised to power n minus r raised to power minus m minus capital N. Okay. Now what is this r over here? This r over here is 10, which causes this decimal number system, right? So radix equal to 10. And then what is this value of n? It is the number of integer digits, right? N represents the number of integer digits. Now how many number of integer digits are there? 1, 2, and 3. So three number of integer digits are there. Now how many number of decimal digits are there? So this m represents number of decimal digits. The decimal digits are 1, 2, and 3. So three decimal digits are there. Now what is the actual number? The actual number is 765.432. Now let's try to solve out this example. How we can write it down is, we can write it down such as this r raised to power n, which is 10 to the power 3 minus capital N, sorry, r raised to power minus m, so that is 10 raised to power minus 3 minus capital, which is the number itself, which is 765.432. Okay. Now this we can write down as 1000, right? This we can write down as 0.001 minus this we can write down as 765.432. Now what does this means? This means 999.999, right? Minus 765.432. Okay. Now again go to your kindergarten and try to solve this problem. 999.999 765.432. Okay, so this will be 765.432. Now this is the 9's complement. This is the 9's complement of this number 234.567. So that's basically the 9's complement of this number, right? So let's try to see. My number was 7. My number was My number was 765.432 base 10. Okay. And then I tried to calculate two things. One of them was the 9's complement, and the other one was 10's complement. What was 9's complement? That was 234.567. That was 234.567. Okay. What was 10's complement? The 10's complement was 234.568. That was 234.568. Do you think some relation is there between these two complements? I see that, and that relation is basically this 10's complement is nothing but 9's complement plus 1, and this 9's complement is nothing but 10's complement minus 1. Isn't this the relation between them? So if 10's complement is present, you know, if 10's complement is present, then that means your 9's complement will be 10's complement plus 1, sorry, minus 1. And if the 9's complement is present, okay, if 9's complement is present, then your 10's complement would be equal to 9's complement plus 1. So based on your comfort level, whichever you think is easier to calculate for you, whether r's complement or r minus 1's complement, you can calculate one, and based on this relation you can easily jump to the another. Okay, now let me try to make a relation between the formula of 9 r's complement and r minus 1's complement. You see, r's complement is equal to r's to power n minus capital N. But what is r minus 1's complement? R minus 1's complement is equal to r's to power n minus r's to power minus m minus capital M. Can I say it's something like r's to power n minus capital N minus r's to power minus m? Now what is this? This is nothing but my r's complement, right? This is nothing but my r's complement. I can see over here. So can I say that r minus 1's complement is equal to nothing but r's complement minus r's to power minus m? And can I also say that r plus 1, sorry, can I also say that r's complement is equal to r minus 1's complement plus r's to power minus m? This is the relation between them. I hope I tried to make this relation clear. Now here just remember this one will be added to the least significant digit of the number. So this is not decimal one, this is the least significant one where it is going to be added. Least significant digit where it is going to be added. Similarly, this plus one is going to be the least significant digit where it is going to be added. Now that least significant digit can be before the decimal point or after the decimal point, depending on what number that is. Like in this case, which was a decimal number, right? In this case where I have the decimal digits as well, the plus one would have been added over here, right? In this case over here. So just please keep that in mind. So this is all for this lecture. In the next lectures, we'll try to see how can we calculate ones and twos complement easily, and then we'll jump further in understanding the subtractions using complements. I hope you like this lecture. I hope to see you in the next one. Thank you.